So this is Unit 4, Lesson 1. Unit 4 is on applications of derivatives. Lesson 1 is on connecting position, velocity, and acceleration. What we're going to learn in this lesson is what is the relationship between position, velocity, and acceleration, and how do we interpret this relationship mathematically. And so motion or change in motion is our first big application of derivatives. So that kind of gives away the relationship mathematically. Here it is. So if I represent position as a function, so S of t is my position function. Position is measured in units of length, so like feet, miles, meters, inches, kilometers. Velocity is measured as change in position over change in time. Which, if you think about that, that lines up with our definition of derivatives. How does a function change over the next value or an independent variable, which is usually time? And so we could say the derivative of our position function, or s prime of t, is equal to velocity. Velocity is measured in units of length per unit of time, so feet per second, kilometers per hour, that kind of stuff. Acceleration is measured as change in velocity over change in time. And so the derivative of the velocity function is acceleration. So v prime of t would be a of t. Or since velocity is the derivative of position, then we could say the double derivative of our position is our acceleration. Or s double prime of t is a of t. Acceleration is measured in units of velocity per unit of time. So if a unit of velocity is length per unit of time, we have length per unit of time per unit of time. So like meters per second, or meters per second squared, you could say. A couple things to note about velocity. An object is at rest when its position is not moving, or in other words, its velocity is 0. So when s prime of t is 0, or when v of t is 0, our object is at rest. Our object is moving in the negative direction, so left or down, depending on whether we're looking at a graph or whatnot. That means our velocity is a negative number. So negative velocity means we're moving closer to or downwards. When the object is moving up and to the right, that means we have a positive velocity. So v of t is greater than 0, means we're moving away from or moving up. So you may be wondering, velocity is change in change in length over change in time, which we also measure our speed in. If you drive a car, it's measured in kilometers per hour here in Canada, or down where I'm from in the States, miles per hour. Raises the question, is speed the same thing as velocity? Well, close, but no, it's not. So speed, like in your car, is only ever a positive value, whereas a velocity can be positive or negative depending on which direction it's going in. So to relate speed and velocity, we would say that speed is the absolute value of velocity. So that's how they relate. A couple other concepts. When is an object speeding up versus when is it slowing down? And how can we tell just by looking at the velocity and the acceleration? Well, when the velocity and the acceleration are both positive, or when they're both negative, that means we're speeding up. If they're both positive, that means we're speeding up or going away from, or going up to the right. If they're both negative, so we're slowing down and we're going in the opposite direction, and we're slowing down more, so we're going more in the opposite direction. That means we're speeding up, but we're speeding up coming close to or going down on our graph. Slowing down would be when our velocity is one direction and our acceleration is the other direction, or when one's positive and one's negative. It doesn't matter which way it is. If one's positive, one's negative, then whatever our particle is or our object is slowing down. So you can think of it, your car is going a certain velocity, like if you're on a racetrack, but if you're slowing down, like if your velocity is decreasing over time, but you're still moving in that positive direction, you have a positive velocity, you're slowing down, so you have a negative acceleration. Okay, so for an example, we had JJ / Joshua / Hichan and Yoon go stand up in front of class, if you recall. Yoon stood kind of by the door on the left side. JJ stood on the right side at my desk. And we had him try to model this graph on the left here, the position graph, as distance from Yoon. And so at first, JJ had to walk towards Yoon to decrease the distance, and then he had to walk away from Yoon for 2 intervals of time, and then he had to walk back towards him. And then we also talked about how quickly he was walking at different times. So he had to slow down to stop, he had to speed up to a max speed or velocity, and then he had to slow down to turn around it and walk back towards Yoon. We also modeled this situation with velocity in terms of how quickly JJ was moving. So we started off moving slow, started moving fast in one direction, slowed down to a stop, picked up speed again, slowed down to a stop, picked up speed again. And so there's a bunch of information here that we could talk about. And we could talk about all this information from the position graph and the velocity graph. Some of this we could talk about from either graph. So moving left versus moving right. If I look at the position graph, if we're decreasing, then he's moving to the left, as in the distance between JJ / Joshua / Hichan and Yoon is getting smaller. As it's going up, that means the distance between the two is increasing. So this from A to B and B to C is when JJ is moving to the right, and then again C to D is moving left. And so if we look at our velocity graph for the second row, we can see this kind of matches up. If the velocity is negative, well, that's when we're moving towards Yoon. And when the velocity is positive or above the x-axis, that's when JJ is moving away from Yoon and the distance is getting greater. And so the position moving left and right, or decreasing and increasing on the position graph, is going to be the same as the positive or negative on the velocity graph. Okay, so velocity, whether it's increasing or decreasing, is going to match up with positive or negative acceleration. So we're taking the same relationship between position and velocity, but we're looking at the velocity and the acceleration graph. And so when the velocity is increasing, shown by the slope of the tangent lines on our velocity graph, then our acceleration is going to be a positive. So if we looked at our acceleration graph from A to B, it'll all be above the x-axis. And because our slopes of our tangent lines from B to D are all downwards, they're all negative slopes, then from B to D on our acceleration graph, it would all be below the x-axis with a x-intercept at B. And so our velocity is increasing and our acceleration is positive from A to B, first 2 intervals, and our velocity is decreasing and our acceleration is negative on the second 2 intervals from B to D. Okay, so speed, there it is again. Remember, speed is the absolute value of the velocity. So basically from the graph, whenever our velocity is moving towards the x-axis, like it is from 0 to A, and from B to C, moving towards the x-axis, note the blue arrows are pointing towards the x-axis, that means our speed is getting closer to 0, which is decreasing. From A to B and from C to D, our arrows, our direction is moving away from the x-axis, so our velocity is increasing, which means, well, it's increasing from A to B, it's decreasing, but in the negative sense from C to D. So the absolute value of the velocity would be moving away from the x-axis. So our speed is increasing on both those intervals. So from A to B and from C to D, we have increasing speed. Our object is at rest. We can read that from either graph. So from our position graph, our object is at rest when our tangent line is a slope of 0. So point A and point C. From a velocity graph, our points of rest are when we have x-intercepts. So again, we can see A and C are the x-intercepts. So that would also be indicative of a moment of rest. Alright, so the Delta Math assignment for this one, you get introduced to Ms. Bunny. Ms. Bunny can be your best friend or your worst enemy. If you try to, because you'll be giving it a velocity dial, so you have to move the dial to recreate a graph by making Ms. Bunny move left and right. If you think of this as a position graph and you try moving Ms. Bunny based off of position, you're probably going to mess up and you're going to get frustrated and you're going to want to not get this assignment, and you're going to email me at 2 o'clock in the morning and complain that it's impossible, Andrew. And so just stick with it. If you focus on the velocity, so not which direction Miss Bunny moving in, but also how fast she's moving, that will help you a lot. Like if she's starting with a negative velocity, so start -5. Start with a positive velocity, start at +5. She's starting out kind of flat, start at 0. And then which direction is velocity moving in, and you focus on the velocity graph. This makes this way easier. So good luck.